But today we are going to kind of shift on the fly, and we are going to discuss what we call an evergreen topic, something that is always good for sprinkler nerds to talk about and learn about, and that is the difference between conventional wire controllers and two-wire controllers. We see the two-wire controllers as an emerging technology, something that is slowly becoming a standard in the irrigation world. And we want to talk about kind of when the two-wire controller application suits your site and when you might consider using the two-wire version in your design rather than the conventional wire. Now, let me jump into the slideshow, get started here, because the slideshow has a very important point to start out with. As I have not secured a second voice on the call today, the special guest is going to be you, the listener. So I am depending on the chat and question and answer box to come alive for me this morning and provide feedback. If any of you would like to join on the call or join on camera, by all means, throw that in the chat box, and Janine can promote us if you want to have a lively conversation with me about this. But I definitely hope that you guys can provide color commentary and provide some perspective on the conversation between conventional wire and two-wire controllers. So as we get started, the theater nerd in me could not resist. Two-wire or not two-wire, that is the question, right? The discussion of why do we choose two-wire and where does it match in application? And to begin that discussion, I really like to identify the key differences between a conventional wire and a two-wire controller. And to do that, I use this little demonstration, this little visual that shows in a conventional wire controller, every valve has two wires, right? Every valve has a hot wire and a common wire that ties the entire system together. So when you are installing a conventional wire system, you need one wire for every valve out in the field and a common wire that ties everything together. So that return path for the electricity so the controller can complete the circuit and do what it needs to do. So when we talk about the difference between conventional wire and two-wire controllers, it is really just the wiring infrastructure that we're talking about. If we are talking about a conventional wire or two-wire site, it does not change the fundamentals of weather track irrigation, right? None of that stuff changes. It doesn't change the automated by weather track schedules. It doesn't change the app management or central management from weathertrack.net. All of the features and functions that we have with the conventional wire controllers, we have with the two-wire controllers. The difference between conventional wire and two-wire really is the difference in how we physically turn on the valves out in the field. And so with the conventional wire, every valve has two wires. With a two-wire system, we have two wires that operate the entire system. So there's only two pieces of wire that run through the entire landscape. And then those two wires not only act as the electrical conduit where we can tap into the electricity, but they also act as communication wire. So on a two-wire system, at every valve, we have a decoder that is like the listening device, right? So these wires that we have acting as communication wires will allow the controller to call out a station, and this decoder hears its number when it's called and knows that it is supposed to do its thing. At that point, it kicks on and it lets the electricity through to the valve, kicks that valve on and lets the irrigation happen, lets the magic happen. So that is really the big difference, is the way that we're turning on valves, the subtraction of a lot of wires in the field, but the addition of a component called a decoder. And this is where, when we get into the benefits of the two-wire system, that's where we have to balance the conversation, right? So if I go into the conversation about, ooh, there's chat. Look at this. Never mind. Side note from Ed Hodnett. So when I talk about the advantages of two-wire, first and foremost, we talk about how it can save money. And the fundamental conversation about how two-wire saves money dates back to this big bundle of wires. So let's just take, for example, a weather track controller that might run 96 stations out in the field on a conventional wire setup. If you have a 96 station controller, that means that A, you have a very large landscape, and B, you've got a bundle of wires coming out from that conventional wire controller that is at least 97 wires, right? 96, each of the 96 valves has its own wire, and then that one wire that goes back to complete the circuit is a big fat bundle of wires, right? That is a lot of copper going in the ground. And so when we talk about copper being one of the most scarce resources that goes into an irrigation system, that wire is a volatile cost and really pretty expensive when you're talking about a huge wire bundle. So when we talk about money savings or dollar savings when switching from conventional to two-wire, it really is all about minimizing the amount of copper that's going into the ground. Because if that same 96 station controller has only two wires, that's a huge savings on that copper wire. But the offset is the cost of these decoders, right? This is a cost add. So we have to drop, to make two wires save money, we have to drop the cost of the copper by more than we add the cost of the decoders. And it's different for every two-wire system. It's different for every site. But I have heard anecdotally that the break-even point for this proposition, this savings, is about starting at about 20 stations, right? That is to say that once you have a station count of 20 stations or higher, you'll save money. You'll spend less on the copper. You'll save enough on the copper to pay for all of the decoders and all of the extra components. So two-wire really is designed for a larger site, right? 20 stations or bigger is where we start to see that savings. But 96 stations, that's a huge chunk of money that you're saving, because that is a lot of copper that's going out into the ground. In addition, there's little ways to save money. We'll talk a little bit about two-station decoders and ways that we can shave that cost down even further. But the advantage really comes in on big sites. On the 20 stations or less, conventional wire, because you don't have to buy the decoders, conventional wire can be a more cost-effective option. However, in certain field applications, I prefer two-wire as well, and I call this ownership flexibility. Many of the different sites that we manage are built in phases. And so if I've got a big HOA, for example, that they're going to build phase one, they're going to put a park, and they're going to put all of the different houses, the model homes in, and complete phase one and sell that off to pay for phase two, right? Once they start phase two, that's where we get into the conversation about the irrigation system, right? Phase one is completely built. We're starting on phase two. And if you have a conventional wire system, when you start to build that second phase, we've got to take all of those wires and home run them back to the controller, right? We've got to cut through an existing landscape and potentially bore under sidewalks to get that bundle of wires for the new phase back to the existing controller. And 2-wire eliminates that need, right? With 2-wire, all we have to do is find where the last valve was installed. We can pick that 2-wire path up and continue it on, and just add valves down the line, continue the run of the 2-wire path and expand the system without having to trench backward, without having to disrupt the landscape or add the cost of trenching in new wires into the existing landscape. So if you've got a system where you're going to expand, it's going to be built in phases, 2-wire is really, really flexible. Or if you've got a dynamic site where conditions change all the time, you might be adding valves in the middle of the landscape. The same holds true, right? If you install a new valve on a 2-wire system, all we've got to do is find the 2-wire path and add that valve onto it, rather than trench a new wire back to the controller. So it does provide an immense amount of flexibility in a dynamic changing landscape, which is something that I like about it. Let's see. Scott has a comment. He says, we generally do anything above 12 stations. This is the city of Colorado Springs. Anything above 12 stations, someone that is an experienced irrigation pulling wires is typically on site to ensure that all the necessary wires go in the ground. That is a big, big conversation with 2-wire. During installation, we want to make sure that the wire path is sound. You don't want to leave this to an amateur irrigation tech, because those 2 wires carry not only the electrical load, but all of the management of all of your field devices. It is a high stakes game. If anything is wrong with that 2-wire path, it can shut down the entire system. And where if something goes wrong with a wire on a conventional wire, we might lose one valve. We lose a wire on a 2-wire system, we could lose a huge section of the system. And what we see, and we talked about in our troubleshooting episode, is issues with wire splices are by far the most common issue that we see with 2-wire. So by all means, if you're listening and you're considering 2-wire for the first time, definitely make sure that you have someone with 2-wire experience help you go through the installation process, because there is a very valuable tool that allows us to strip those wires without causing any sort of exposed copper that can be the long-term demise of that 2-wire path, right? That will cause you to come out and have to troubleshoot. And make sure that, first of all, every splice is sound and tight, and second of all, we are using the direct bury wire nuts. Now, in the irrigation world, these kind of get a bad name because they are full of goo, and irrigation techs don't love to work with them because the DBRY-6, the specified wire nut that we're going to use on every 2-wire connection with WeatherTrack, that WeatherTrack provides as part of the purchase of the device. In every little bag with a decoder, we send these proper wire nuts, and it's important that they get used because 2-wire is a little bit different than standard irrigation. With the standard irrigation wire nuts, they do the job on a conventional wire system because there's only current on a conventional wire controller when that station is on. But with 2-wire, there is always voltage on this 2-wire path. And what we see with those lesser wire nuts, those landscape or irrigation standard wire nuts, is that the silicone inside the wire nut isn't rated to handle that constant voltage. And when we apply that constant voltage that you get on the 2-wire path, it actually just melts out the silicone that's inside of those wire nuts, which long-term doesn't do the trick, right? It allows water to get in and shorts to happen and bad stuff. So we really want to be very specific about the type of equipment we are installing with the WeatherTrack 2-wire. Another good question, here we go. Some 2-wires can send out DC power, yes. And the decoder actually converts the AC to DC without the valve solenoid. Is the 36 volts on a WeatherTrack? Yeah. The WeatherTrack has constant 36 volts of AC. It is not a direct current setup. There are some. Those direct current setups are great in certain applications that don't require that constant voltage, right? It's just a one signal on, one signal off light switch, but it doesn't provide the kind of response that we want and the kind of analysis that we want. So with WeatherTrack, it's all AC, and it's constantly, that 2-wire path is constantly charged with 36 volts all the time. And that's what melts all of the goo out of the wire nuts. Oh, okay. So, snafu. I think I messed up. There we go. Thank you, Janine. All right. So, questions for me in the chat box about kind of the benefits, the cost and benefit of choosing 2-wire over conventional wire controllers. I'm going to open up the chat. Anybody? All right, so now we are going to break into something that I've never done before. It's an experiment I want to try on you. I want to try to take you guys into what I call WeatherTrack Studios, and my little home office here that I am surrounded by WeatherTrack nerd stuff, and show you the physical differences in the controller between a conventional wire controller and a 2-wire controller, and highlight some of the benefits of the H2O hardware. Okay, so it's going to take me just 1 second. I got to switch over to my camera and switch my microphone. Okay, hopefully you can hear me. Welcome to WeatherTrack Studios. Here is all of my fun ear testing stuff. That right here, the WeatherTrack LC. You recognize from some videos as the mobile app, mobile mapping, which I use my little mouse to demonstrate. So my little thing, or my little icon as I walk around the site. Guys right here are our corporate demo called Red Rock HOA, where I can demonstrate OptiFlow firmware. And today we're going to be looking at this guy right here as our conventional controller option, and more importantly, this guy right here as our 2-wire controller. So first, let's take that off. If you want to see how nerdy I am, I actually built a full 2-wire system that I attached to a 2-wire controller.
Hey, Ben?
Yes?
Any chance you could go back to your computer audio?
Yep. Is it bad? Got it. Thank you. Let's try that. I will go back to this guy and I'll carry the mic. Is that better?
Yes.
Okay. Let me try this guy. So, what I have here is just a quick little, it's a full 2-wire system that I built so I could test all of the decoders and see how everything gets wired together on my demo 2-wire controller. So what we want to show off here is just some differences in the hardware between the conventional wire WeatherTrack and the 2-wire weather track. All right, so if we zoom in here, it really does boil down just to the electrical components, and you see here all of those wire terminals. Right, this is a 24 station controller. I've got 24 ports for individual field wires, and I've got 1 port for a master valve, and I've got 1 port for a flow sensor. Very importantly, with the conventional wire weather track, we are able to handle as many as 4 master valve and flow sensors set up on a conventional wire controller. But we have to have certain station counts, because each one of these boards has only 1 master valve and flow sensor port, right? So to get a second master valve and flow sensor, I need at least a 36 station controller, because it adds that second board that has the second master valve and flow sensor availability, the ports where I can wire those devices in. And again, for the third one, we have to have a 72 station, and for the fourth one, we have to have a 96 station. So this is just what you're used to with WeatherTrack. This is just the conventional wire setup. Now, if I switch, let's see if I can do this on the fly. Now, here we have the H2O 2-wire, right? So the wires that I'm using is just, there's so much less wire. This is the entire system coming in on this 1 wire path. It's important for WeatherTrack designers to know that there are actually 3 different ports where, let me see if I can not have my arm in the way. 3 different ports where we can wire those 2-wire paths in. And so I definitely encourage you to, if you're designing a 2-wire system, to use all 3 of those ports. Have 3 2-wire paths that go out so you can isolate different sections of the property when troubleshooting. Having your site sectioned off on different 2-wire paths makes it easy to eliminate big chunks of the landscape when you go out to do troubleshooting, because you'll be troubleshooting 1 wire at a time. And so if you can have half of your system on one and half on another, it makes it much, much easier to troubleshoot. So 3 separate ports to plug in 2-wire paths. And then once they're plugged in, it's seamless, right? You don't see any difference in the performance. WeatherTrack knows how to manage all that logic. And the other thing that I wanted to highlight here in the hardware is this little board right here. One of the great options that we have with the H2O is when we talk about wiring in master valves and flow sensors. This little wire block right here, while it looks like the valve wire terminals from the conventional controller, this is actually for all of our master valves and flow sensors. With the H2O, wiring in a master valve and flow sensor is something that we give you options for. So first of all, if you have a master valve and flow sensor and you want to have that stuff added to the 2-wire path, we absolutely can do that. Each master valve on the 2-wire path would need a master valve decoder. Every flow sensor on the 2-wire path would need a flow sensor decoder. But this little guy right here gives us the option to direct wire those components into our controller, right? So it can run a designated wire for each of 4 master valves and each of 4 flow sensors if I choose to. And at WeatherTrack, we prefer this option, right? We prefer to have you direct wire those components into the controller. And the reason for that is that if you're running a 2-wire system, let's pretend you've got your main line and your 2-wire path running in the same trench through your entire system, and you take a trencher right through your main line and your 2-wire path at the same time. The fact is, if that happens, there can be enough interference on the 2-wire path because of that break that it won't be able to reach out and close the master valves, right? It won't have any actionable or any ability to action any component of your irrigation system. So even if it tries to close the master valve in response to a mainline break, there might be enough interference on that 2-wire path that the signal won't get through. And so we give you the option to direct wire those, so it eliminates that potential risk, right? If you direct wire those, or run a specific wire for each master valve and flow sensor, then it minimizes the risk that the insurance policy that you have in master valve and flow sensors will be affected by some sort of on-site failure, right? And so we think that this is a much safer way to go, and something that I wanted to highlight as kind of the key difference between what WeatherTrack offers. Just to be 100% clear, this is a mix and match situation. It doesn't have to be all one or all the other. If we are retrofitting and some of your flow sensors are close enough to wire them directly, but some are so far away that they have to be on the 2-wire path, you absolutely can do a mix and match of that. You can have two master valves on your direct wire, 2 master valves on the 2-wire path, mix and match as you like, right? But the direct wiring option is a super valuable one, and we think it will improve your success in responding to on-site issues. All right, let me go back to my computer here. Are there any questions? No questions in the Q&A box? No questions in the chat box? All right. Then we will just wrap. Let me go back to this. I think that wraps us up. So sorry, I'm gonna pull my microphone and pull my integrated camera. Hopefully that was successful. On the fly, live from WeatherTrack Studios. If you guys have ideas on ways that I can use all of this fun stuff that I have in my office, please give me a shout. If you have ideas for episodes, I'd love to hear them. Send me a request at bcoffee@hydrapoint.com. I would love to hear what you guys want to hear on the show. Let's talk about Brian's question. Brian says, show me chat. Master valve decoder or single valve decoder for master valve. We have a specific master valve decoder for that. It is very similar to the single valve decoder, but in the pricing guide, you want to order a master valve decoder for every master valve that you're running on the 2-wire path. So you'll buy a master valve decoder for master valves and flow sensor decoders for flow sensors. All right. Awesome sauce. And then, so that was, we were going to talk about the dual valve decoder as well, right? One decoder that can manage 2 valves in the same valve box, preferably. So if you want to save a little bit of money, that's an additional way to save time and money and save cuts on your 2-wire path. Save yourself a couple of splices on that 2-wire path that is the most common place that we fail. All right, which brings us to the end. Of course, we always want to reinforce that we are here to help. If you need support, you can call our support team at 1-800-362-8774. Check out our libraries of online available support materials, including all of the product documentation, as well as frequently asked questions guides and all sorts of fun stuff available at both the knowledge base and at our homepage, hydrapoint.com. And then the online on-demand training that we provide at hydrapoint.learnupon.com, as well as many training resources on YouTube and anywhere I can find to stash training resources. So thank you so much for tuning in. Next week, I promise we will have John Ross on, and we'll talk about how to take on a big retrofit project with WeatherTrack and all of the ins and outs of specifying the right product and understanding what you need before you purchase a big WeatherTrack retrofit project. All right, so I'm gonna put it out there, one last option for any questions that exist. Going once, going twice. All right, thanks everybody for tuning in. I hope to see you next week.